and thank you for joining us this morning. And what we're going to end up talking about is the introduction of the Neo4j Graph platform as part of our 3.3 launch. We'll go through the new capabilities in Neo4j database, specifically version 3.3. We'll talk a lot about some of the new graph algorithms that we've introduced, some of the data integration capabilities, and then finally the Neo4j desktop, which I think all the developers in our audience should really appreciate, and is certainly focused on helping you be more productive as you continue your use of Neo4j. So the big announcement that we made at Graph Connect back in October was the introduction of the Graph platform, and the goals of the Graph platform are really revolve around addressing the myriad of needs of our customers and creating an environment that fits more appropriately within your core ecosystem. So I'll keep kind of coming back to this diagram as we build it out, and this will kind of drive topically where we go, both in the presentation and what I'm talking about in the product itself. As I do that, of course, the core intent of the platform itself and our motivation behind moving our discussion from solely being the leading graph database to moving into the being the leading graph platform is to really continuously address ongoing customer and product needs as we looked ahead. So our core focus as we look at this, and I just want to quickly give you a sense of what we were driving for, and then we'll go into core sets of features. The number one request that we get from customers, from our own field people, our own users, from the community itself, is continued investment in improving write performance. We know that read performance is very fast within Neo4j, but improving the ability to get data into the database was a primary driver for this release. We want to continue to improve that developer experience with the introduction of the Neo4j desktop, which is basically an application or a packaging or a wrapper around core Neo4j features that a developer can use for free in their local environment, on their local machines. So you can use it as your development environment, and then when you push to production, it will also actually eventually connect to your production machines as well. And then we wanted to continue that developer experience focus also with introducing the asynchronous drivers to improve throughput with the drivers themselves. Now, when we looked at the enterprise capabilities that we've introduced, these two are setting us on a path to continuously support both larger and larger graphs and more geographically or cloud dispersed graphs. So new capabilities we've introduced, intra-cluster encryption, as well as improving the execution of Cypher queries themselves. And on the enterprise operator, the admin side, making manageability improvements, improving space reuse, and making it so that you don't have to always restart Neo4j when you have configuration parameters that you're changing. And then, of course, improving the scalability of clusters and graphs, including new load balancing features, support for IPv6, and then improving the ability to tee up if you're doing a lot of transactions all at once, prefetch IDs so that you don't have to keep looking for ID numbers every single time that you're adding a record or adding a node. And then there's some really, really cool things that I think everybody's going to enjoy. We're characterizing this as the shiny new things to play with from our Neo4j labs. That includes making the exercise of getting relational data into a graph significantly easier, making graph algorithms available in the product and the packaging, and extending ourselves into corporate infrastructures and corporate ecosystems by introducing new support for Hadoop environments and in particular in-memory Spark processing of graphs. So our core belief here as we released the platform and as we built it out, one of the drivers was to support and address the needs of more enterprise users, roles, and core sets of use cases that we see in the in an organization. So one of the realizations that we had was while we're very good at focusing on developer and product management kinds of needs in an organization, that's the upper left-hand corner here. We've seen that as the projects that we're deploying now succeed, and I'll talk about a couple of those in a minute, as they succeed, Graphs are indeed hungry for more data, more connections, more relationships, and so the improving the capabilities and the relationship between our core developers and the big data IT architecture folks in the center of this slide, and then starting to navigate around that infrastructure, that big data infrastructure, as basically an information hub or the core data hub, so that we can then improve the connections between data scientists and developers as they build new features into their real-time traversal applications. That particular section oftentimes I refer to as my AI loop, because as the graph grows and needs more information, we go and fetch that from the big data infrastructure. That forces changes to the queries and to the algorithms that we use upon the data, because it's got new capabilities in it, and then once those algorithms themselves are defined, inserting those core sets of new features into those real-time graph traversal applications. All of that exercise is something that we are indeed seeing quite a bit within our install base. Another interesting one is the relationship between the data hub, data scientists, and analysts and business users. Their need for consistency and their need for a central, almost the traditional data warehouse kinds of central information. We're starting to see our knowledge graph practice build out of that particular loop of improving what data is going into the overall knowledge graph, and how that institutional memory or institutional knowledge gets built up, feeding it with documents, with NLP information, with new information coming from externalized sources, and then giving that to both data scientists as well as everyday users to use in their decision-making processes. I might consider that one, like I said, my knowledge graph kind of loop. And then the third, the other interesting one there is when we start to address the needs or talk about the needs of officers of initiatives on the far right-hand side. Those folks are typically in charge of some kind of a core initiative in an organization, like risk management or compliance or the digital transformation kinds of activities, coming up with what's the next great big thing that organization is going to do. Well, oftentimes they actually are discovering that they have very graph-oriented problems that they can, if they apply graph to those problems or to their ideas, they can come up with something really quite impressive in their organization. So really, much of the goal of this is to identify both the number of people in the organization that we can help address the needs of, and we'll walk through that as we go through the platform kind of diagram itself, and then keep thinking in terms of the different types of applications that we're deploying right now. Those things include the real-time recommendation and fraud detection kinds of applications that we're known for, but they also include things like cybersecurity, network management, IT operations, metadata management is becoming very big. Customer 360 kinds of applications are becoming very big, all of which because they describe the relationships of people, of the processes within which they're operating, and of course the digital systems upon which they're operating or that they happen to be using at any given time. So the graph is a really great way to meld all of those three elements. So let's start to talk about the core capabilities now in in the graph platform, I'm going to basically work counterclockwise around this diagram and talk to start with the core database. It's Neo4j 3.3, the database itself, and its support for our traditional graph transaction type applications. And then as this diagram builds, you'll kind of see where other areas that we've addressed. So the graph database itself, areas where we've continued to invest for these transaction processing applications is what we'll go through. And as I said earlier, some of the major things that we were focusing on were performance improvements in writes and reads and writes in the database. So some of the things that we've added into the database itself in support of this, most notably, is the continued adoption of native indexes and the replacement of third-party products that are used for indexing and writing native indexes directly within Neo4j itself. So you'll recall in version 3.2 we had added native indexes for labels themselves. Now we've added native indexes for all numeric properties, so that that pretty dramatically improves inserts and updates. And even if you happen to have a property that sometimes can be numeric and sometimes could be text, the numeric will be assigned the native index, and the text would be assigned the traditional Lucene-based index as it lives today. But I think this is really helping chart where we're going with regard to improving indexing and improving the write speeds inside the database. We've added some great improvements to the bulk data importer. We've improved its memory efficiency by 40%. I think I've got another slide on this in a second, but we'll also write out to page cache if we're using too much memory in the bulk data import exercise. So it's both cleaner and much more efficient. And then if we're writing to lots of nodes at once, we've got the ability now to prefetch IDs in handfuls or batches rather than going one at a time, which was a kind of a pesky bottleneck, if you will. On the read and write exercise, runtime itself is about 55% faster than even 3.2, as you can see in the graph to the right. And I think the way to really read the graph itself is to recognize that we are operating in this continuous improvement, continuously make Neo4j more and more efficient in support of very large graphs and very high performance graphs from release to release to release. So this is now the fifth consecutive release where performance in the same environment has improved, and in this case pretty dramatically. My final one here I'll mention too is the page cache metadata. When you've got a very large graph, oftentimes the metadata for the page cache itself we would leave in the memory heap, but actually we found that as the graph grows, that conflicts with actually giving way to space that the graph should have rather than the page cache metadata information should have. So we moved that to the page cache. And now on clustering for Enterprise Edition, there's some great new improvements to both our clustering and the bolt drivers themselves. So we now support least connected load balancing, and what that really means is over the round robin load balancing that we were offering before. And what this does is it improves overall cluster throughput by actively seeking out the live servers that are actually carrying the fewest number of live connections. And when you look at the way that this is designed, it still includes all of the computing rules or the routing rules, like routing priority, such as route this piece of information to a particular data center for consistency's sake or for locality's sake, supporting the read your own write consistency rules that we adhere to make sure that your transactionality, your ACID compliance is indeed always intact and always delivers the the user experience that a user or the application expects. So this new least connected load balancing allows all of that to happen very efficiently, and then makes but works within the way bolt drivers are supposed to behave anyway. We've added support for IPv6, and that's more an availability and a clustering availability for clustering capability. And then finally, we've also introduced intra-cluster encryption. So now all traffic that goes from one server to the next inside of within Neo4j is encrypted within Neo4j itself. So we manage that and take that burden off of you. So you no longer need to set up your own VPN or trusted network. It'll operate across both data centers or cloud zones. We're managing those, the encryption and the certificate handling ourselves, and makes it much easier for you to deploy certifiable or regulated kinds of applications. So those are the kind of the core capabilities that we added to the database for transactional applications. Now let's talk about what we did to the database in terms of supporting graph analytics. And here we're investing quite a bit in adding both, taking advantage of some of these new speed capabilities, taking advantage of the capabilities of Cypher for both developer productivity's sake as well as expressiveness sake. Cypher continues to improve. We've added a variety of very robust APOC procedures, and specifically about 10 brand new graph analytic procedures we've added into the environment, and these do things like look for the correct pathways through a graph, or eventually you'll see us labeling paths, and eventually you'll see us do things like identify who the largest influencers are within a cluster or a cohort, like a PageRank kind of algorithm. And then we'll also look at navigation, flow, movement of resources, etc., and integrate with other analytic environments is sort of the final idea around here. But the algorithms that we've added in, like I said, support centrality, support PageRank, support pathing. Those are some of the key ones. When we compared ourselves to what most organizations, many of our customers are doing right now in terms of looking at, let's say, a large-scale activity like a union find all connected components, right? That's a pretty big query to be executing, and oftentimes customers are just choosing to not execute that inside of Neo4j, but do that in something like Spark and using Graphx. And then when they find whatever they're looking for, they define what the structure of the new graph is going to be, then they translate that back into Neo4j for their operational applications. So in these particular tests, you can see our environments are very similar, 128 CPUs each. The Graphx environment had 68 gigs of memory and 2 hard drives. We had 55. Neo4j had 55 gigs of RAM with solid-state disks, and you can see that executing these two types of queries upon the same data set, we came in about half the time or about, let's say, 2/3 the time of Graphx in that union find exercise, and almost 75% faster in the PageRank exercise. So the investment in those graph algorithms kind of capability is indeed can pay off great dividends. And so when we look at how we're going to end up applying this, it's really a blend of what I described earlier, of addressing the needs of those core users like data scientists and big data IT and our core developer community, and building things like knowledge graph, in building and providing visibility to AI activities. So providing visibility into how a neural network might have executed a particular thought or series of results by illustrating the graph that it actually navigated, creating graph decision and systems of record kind of capabilities, or enhancing existing AI models using these page rank and density and type of graph algorithms, and executing overall execution of AI operations. So when you actually do operationalize that, you can insert intelligence into your application such that one of my examples when I talk about the recommendation engines that some of the customers are deploying. The recommendation engine itself is not only looking for what products to recommend back to a shopper based on the requirements they're submitting, but it's also looking to build out the long-term knowledge or the institutional knowledge of that particular shopper and the attributes that individual might have, like they carry an iPhone, or they are left-handed and shopping for left-handed products, or they are size 9.5 shoe, right? Those kinds of attributes create a really personalized and contextual type of environment for that shopper, and we need to build up that knowledge so you can actually insert the logic to identify those kind of attributes as the user is interacting with your system. And here's a great example of that, is the eBay Shopbot example is oftentimes what we draw upon. The Shopbot knowledge graph here really has categorization of different types of products. The red node in the middle says bags, and when we go shopping for, when a consumer comes shopping for a particular type of bag, the first decision or the first question that Shopbot might ask back is, are you looking for men's backpacks highlighted in purple on the left, or are you looking for women's handbags highlighted in purple on the right? So it starts to gain that kind of context based on what the decisions are that are provided by the customer. Like in this case, can you show me a brown leather coach messenger bag for under $100? So each one of those might be a prompt that Shopbot is actually making to the shopper while interacting with them, and then ensuring that they do indeed have products that fit those particular parameters to offer that individual as they start engaging in the buying process. Another great example that is quite fresh is the Russian troll graph, and what this is depicting is the types of articles that were being distributed via Twitter. Who are they talking about, and then whether it's John Bell Edwards, whether it's Donald Trump, whether it talks about location specificity, where these things are going on. It applies a particular subject type to it, like whether it's politics or news, or particular locales, like or topics like the issues around Baton Rouge, or the trade PPP kind of, oh, those are users themselves, forgive me, who are posting these things. So the troll graph here, very interesting. The metadata for that is really quite simple. Blue is a user, tweets are what's coming out, what they're talking about, whether they're hashtagging it or linking it to something, and then what other entities does it contain, whether it's locality, organization, or another individual being mapped out in that graph. And then following this will give you a very strong sense of the topics that were important going on in Louisiana around June of last year. And finally, we had a great other example is we've got GraphAware's natural language processing graph is actually taking and highlighting terms from documents and terms from it turns from documents that they're reading in, and then making sense of all of that. Whether there's personnel issues, training issues, contract issues regarding equipment, regarding performance of equipment, regarding other types of elements, and this is all being drawn from documents themselves and then mapped into a graph such that the topics and the sets of issues can be traversed much more naturally. And we're seeing a lot of different customers deploy an NLP-based kind of graph, or a text processing kind of graph, and that's from whether it's equipment or maintenance equipment, supply chain activities, the article investigation, investigative journalism. Of course, you guys all know the Paradise Papers is a huge activity going on that is powered by Neo4j underneath it. Also another example of that text processing and topically assigning or associating people, activities, and in Paradise Papers situation, financial accounts and their locations. So let's now transition very quickly into data integration activities, and here we'll look at a little more deeply into the Neo4j ETL capabilities and what we're going to end up offering here, and then how that relates to the 3.3 importer and some of the things that I just mentioned earlier. So the ETL interface we now have, it'll do a mapping of relational information into graph. I'll show you a picture of that in a second. For the open source, it will support your favorite open source databases, MySQL, MariaDB, Postgres, and then on the commercial side, it will support Oracle, SQL Server, and others. And in the future, we're anticipating this being one of the foundation elements to what I'll call the data lake integration capability. And the exercise or the activity that it's doing is it's looking at properties and labels of rows and of tables and turning those into nodes, and then using join logic and foreign keys to identify what a relationship might be once it is materialized in a join. And then the effects that has is what it's ultimately doing is preparing, let's say, a graph-ready set of CSV files to be loaded in via the 3.3 importer. So this, of course, is been worked on quite a bit to make importing information much more efficient. It's multi-threaded. It'll page to disk when you run out of memory. And one of our most recent examples of loading information was loading in a financial graph of 170 billion relationships from 17 terabytes of data. Really impressive size of graph here, and this is all designed for you folks who are either iterating and constantly refilling new graphs, or those of you who are indeed starting new projects, or for our own internal people, those who are working on multiple projects at any given time. So here's what the Neo4j ETL interface looks like. You can see, you can evaluate the metadata about the schema of the relational database on the right hand or left hand side, inspecting that, and then start to assign what its particular nodes, and then also what tables it's related to when you're like supplier, customer, employee, when you're going to import this information, and then taking and typing, identifying what data types you might want in the graph itself, and then you can see on the right hand side what that starts to look like when that gets imported into the graph itself. It's pretty cool. So let's keep going on this data integration types of activities, and some of the analytic tooling that I want to talk about. And what a lot of this is going to revolve around is the introduction of Cypher for Apache Spark. Now, this is a pre-release set of code. It's being released through the OpenCypher.org organization and project. And what they've done is they're releasing it under the Apache license, so it's very friendly for Spark environments. And what it does is like Spark SQL operates on relational information, Cypher for Apache Spark creates graphs out of data that would be drawn into Spark and as a computation engine. And then as it needs to evaluate and operate upon that information, it does so using Cypher instructions as the query vehicle, and there's some really clever features that this implementation of Cypher happens to have, including the ability to return results as a graph in addition to what it does today, which is return results as a table. So we call that composability. It's a composable language now, just like SQL is. You can query SQL over, cursively over and over again, and keep getting new and different, new and more shaved down results from supporting, queries upon queries. So the cool thing about this is now we can make subqueries and chain link Cypher query algorithms to support larger activities like figuring out customer churn, or figuring out propensity, or figuring out market basket analysis kinds of capabilities. Those are activities that might have multiple passes over sets of data or over graphs themselves. And in terms of this, Cypher now supports this ability to query itself over and over again. We can also build graph expressions, so which helps us to combine two graphs into one, for example, and we will start to define new graph object types like a walk across the graph, or runs through the graph, and pathing through the graph, so that once you've established a reliable route, you don't have to necessarily traverse all 20 nodes that through that kind of traversal. You can skip that and jump to the direct run to the node that you're going to land on. So Cypher, as I said, is evolving really rapidly. This introduction of Cypher on Apache Spark, we call it CAPS, is actually the new reference implementation of Cypher itself, and future versions of Neo4j 3.4 will start to support the same sets of features that CAPS does here. But and CAPS is, as I said, released as a pre-release product right now through the OpenCypher organization, and what we're really looking to see is and gain is a wide degree of market adoption and suggestion as to how Cypher and this tooling should be evolving over time. Cypher's popularity is certainly still on the rise. The OpenCypher initiative as a drive to create a standardized query language for graph, very similar to SQL, is gaining great traction, and it continues to be what we believe is the most popular graph query language being used in the world today. Now, I'd alluded to earlier this idea of a data lake integrator kind of product or kind of capability as well. And what this does is it starts to combine the capabilities that I've introduced a moment ago from both the Neo4j ETL functionality as well as the Cypher for Apache Spark functionality. Just different ways in which to obtain and distill graphs from non-graph data. The interesting one here is this data lake integration capability also adds the ability to read in or write CSV files directly from HDFS. So circumventing even some of the pre-processing that I've described here, we can take CSV files and distill them into graphs directly from a customer data lake, and then the beauty of this is it doesn't necessarily, if we're operating through Spark, then the data itself is all in memory and it's not it doesn't have to be persisted for any time longer than is needed. even if it is manifested through Spark, we can actually take snapshots of graphs, and so you can have a daily snapshot, and you could compare and then save that as CSV files instead of saving it as graph, as a live graph, and then do diffs against those CSV files to see what changed from from day to day kind of thing. So some really great possibilities are we're starting to identify here in this Data Lake Integrator set of capability. This is it will ultimately be a commercial enterprise-oriented product. We do have pre-release code of it available for our enterprise customers to give us feedback on. And if you're interested in pursuing that with us, certainly engage your local sales team, either your SE or your rep directly to obtain access to this through product management. And then lastly, we'll touch on the discovery and visualization kinds of capabilities for sets of business users, and really what's certainly what I guess I've observed in the world of Neo4j as I've now been here for a little bit, the linking between what our transaction-oriented developers were doing and their ability to address or communicate the benefits of their graph to their business user type of colleagues was a couple of leaps away. And as I had said, it was leaps through that data hub to get to these types of users. Well, what we're doing now is improving our partnership with the visualization vendors and using those guys to actually help explain not only to those business users but pave that path to initiative holders. Here's how and why the graph and navigating the graph and performing the graph analytic exercises we just described is so important to the next set of initiatives that a company might be taking on. So I'll often refer to the graph explorers as that kind of audience, in addition to the data scientist, data administrator, et cetera, and big data admin folks that that we feel that we're able to reach now through this this platform strategy. So that ultimately, I've re-illustrated the platform itself, and now let's talk finally about what the investment that we've done for development users themselves actually is. And we've introduced the Neo4j desktop package, and it's really the way to look at this is it's the mission control console for everything that you might want to be doing now or in the future in Neo4j. It's almost like it's a launcher for existing technology. It's an installation tool for retrieving the latest version of elements that you might want to be drawing down from Neo4j or drawing down from any of our partners or application environment builders. So if you need to update the APOC library, if you need to update your driver libraries, the Neo4j desktop will grab those directly. If you need to upgrade your JVM, the desktop will fetch that, in addition to offering you the ability to use Neo4j 3.3 Enterprise Edition as your local development tool. And the reasoning behind this is because we want to make sure that you're at a minimum exposed to the developer-oriented features that are inside of Enterprise Edition, such as the property existence constraints and node keys and user roles and LDAP integration, right? All of those capabilities are built in Enterprise Edition, and they are not available in community, and leaving that as an exercise for you, the developer, to actually begin to operate it or figure out how to implement yourself. We felt like that was it's better for the developer to experience that directly, what we put into Enterprise Edition. Two elements to this that I think are really, really important. One is you get access to Neo4j Enterprise for local use on your local machine. non-production use, so it can be used as a development type environment, but not production. And what it requires is basically just registration. And then after that, it's a free license. It's to use this environment. And as I said before, as we look ahead to some of the things that it will do in the future, it will be able to connect to servers and clusters and offer the access to the administration capabilities like query management that are built into Enterprise Edition. It will be able to access cloud services. It will be able to access third-party applications, and as we demonstrate this and folks to get used to it, you'll see that it includes a number of integration tiles or launchers, if you will, and those don't necessarily have to be things that Neo4j builds. They could be things that you build, and or the community builds. So community-oriented applications can be integrated into the desktop really very, very easily. Now, as I wind down my my core sets of features, what do we put into Community Edition versus Enterprise Edition? Those are listed here. The big things include Cypher for Apache Spark, the native indexing, graph algorithms, Neo4j ETL for open source databases, and then the rest of the activity happening around OpenCypher. Those are all Community Edition oriented types of features. Enterprise Edition features include desktop, as I said, the server encryption, IPv6 support, least connected load balancing within the Bolt drivers. Those are primarily the things that we've added for exclusively for Enterprise Edition. So there you are, the kind of the layout of the graph platform itself.